Between the silent borders of Mars and Jupiter, a shimmer of motion betrayed the calm. For weeks, it drifted unnoticed. A grain of reflected light among billions of digital readings stored in NASA's vast archives. Then, in one ordinary evening shift at the Jet Propulsion Laboratory, a line of numbers refused to obey. A tiny anomaly had appeared in the path of an interstellar visitor known as 3I Atlas. A fragment first recorded when it crossed the edge of the solar system. According to prediction, its course should have been exact, its descent through the outer orbits predictable, but the latest data whispered otherwise. The coordinates had shifted, subtly, gracefully, yet undeniably. Welcome to Science Reshaped, where data becomes discovery. If you want more journeys like this one, hit subscribe and join us as we decode the whispers of the universe. At first, the deviation looked like noise, the kind of phantom pattern scientists see when a telescope blinks, or when the solar wind murmurs across antenna dishes. But cross-checks from observatories in Hawaii and Chile revealed the same half-degree divergence. It wasn't an error, it was motion, deliberate in its smoothness, quiet in its precision. The analysts re-ran the models, the numbers held. Something in the darkness had changed direction. Inside the sterile white glow of the lab, the translation from numbers to movement began. Columns of raw photons became color, color became motion, motion became meaning. The faint blur that was once a routine data point had rewritten its own trajectory. Astronomers spoke in hushed tones, not from secrecy, but from awe. An interstellar body, one whispered, should not act as if it remembers. 3I Atlas, named after the survey that first caught its light, had already fascinated the world once, but this time its defiance was subtle, a feather drifting against the wind, a shift too elegant to belong to chance. Even the skeptics felt it. Gravity hadn't pulled it, solar pressure hadn't bent it. Nothing measurable could explain that delicate correction. Yet the object had clearly adjusted its path. At 02:14 UTC, its brightness flared just slightly, as if a frozen mirror had turned its face toward the sun. Hours later, predictions and reality no longer aligned. To the naked eye, space was unchanged. But in the precise language of physics, something fundamental had spoken. Some researchers proposed it was outgassing, jets of vapor escaping from subsurface ice. Others blamed radiation pressure, micrometeoroid strikes, or residual heat. None of it fit. The event happened too fast, too cleanly, too rhythmically. Across deep space telemetry, a pulse began to emerge. Once every 6 hours, the light brightened, then dimmed again. Regular, predictable, alive in its symmetry. No one dared call it a signal. They called it a periodic photometric variation, a phrase safe enough for science, poetic enough to haunt, a heartbeat in the void. Weeks would pass before the story reached the public, but among those watching the data in real time, the feeling was undeniable. This was different. Not dangerous, not dramatic, just profoundly alive with meaning. To a telescope, Atlas is only a speck of borrowed sunlight. Yet within that glimmer lies a question that unsettles every certainty of orbital mechanics. What kind of force, unseen and unnamed, can cause motion to remember? Perhaps trapped gases exhaled beneath its crust. Perhaps stresses deep inside the rock had woken after 1 billion years. Or perhaps the universe itself had reminded this traveler of a forgotten path. Every time humanity measures the heavens more precisely, the edges of ignorance expand with it. The clearer the picture, the stranger the truth becomes. And now, somewhere between two planets, that truth had moved, not wildly, not violently, but with the grace of something that understood exactly what it was doing. Between the silent borders of Mars and Jupiter, a shimmer of motion betrayed the calm. For weeks, it drifted unnoticed. A grain of reflected light among billions of digital readings stored in NASA's vast archives. Then, in one ordinary evening shift at the Jet Propulsion Laboratory, a line of numbers refused to obey. A tiny anomaly had appeared in the path of an interstellar visitor known as 3I Atlas. A fragment first recorded when it crossed the edge of the solar system. According to prediction, its course should have been exact, its descent through the outer orbits predictable. But the latest data whispered otherwise. The coordinates had shifted, subtly, gracefully, yet undeniably. At first, the deviation looked like noise, the kind of phantom pattern scientists see when a telescope blinks, or when the solar wind murmurs across antenna dishes. But cross-checks from observatories in Hawaii and Chile revealed the same half-degree divergence. It wasn't an error, it was motion, deliberate in its smoothness, quiet in its precision. The analysts re-ran the models. The numbers held. Something in the darkness had changed direction. Inside the sterile white glow of the lab, the translation from numbers to movement began. Columns of raw photons became color, color became motion, motion became meaning. The faint blur that was once a routine data point had rewritten its own trajectory. Astronomers spoke in hushed tones, not from secrecy, but from awe. An interstellar body, one whispered, should not act as if it remembers. 3. I-Atlas, named after the survey that first caught its light, had already fascinated the world once, but this time its defiance was subtle. A feather drifting against the wind, a shift too elegant to belong to chance. Even the skeptics felt it. Gravity hadn't pulled it. Solar pressure hadn't bent it. Nothing measurable could explain that delicate correction. Yet the object had clearly adjusted its path. At 02:14 UTC, its brightness flared just slightly, as if a frozen mirror had turned its face toward the sun. Hours later, predictions and reality no longer aligned. To the naked eye, space was unchanged. But in the precise language of physics, something fundamental had spoken. Some researchers proposed it was outgassing, jets of vapor escaping from subsurface ice. Others blamed radiation pressure, micrometeoroid strikes, or residual heat. None of it fit. The event happened too fast, too cleanly, too rhythmically. Across deep space telemetry, a pulse began to emerge. Once every 6 hours, the light brightened, then dimmed again. Regular, predictable, alive in its symmetry. No one dared call it a signal. They called it a periodic photometric variation, a phrase safe enough for science, poetic enough to haunt, a heartbeat in the void. Weeks would pass before the story reached the public, but among those watching the data in real time, the feeling was undeniable. This was different. Not dangerous, not dramatic, just profoundly alive with meaning. Midpoint insertion. You're watching Science Reshaped, where data becomes discovery. If you want more journeys like this one, hit subscribe and join us as we decode the whispers of the universe. Continuing narration. To a telescope, Atlas is only a speck of borrowed sunlight. Yet within that glimmer lies a question that unsettles every certainty of orbital mechanics. What kind of force, unseen and unnamed, can cause motion to remember? Perhaps trapped gases exhaled beneath its crust. Perhaps stresses deep inside the rock had woken after 1 billion years. Or perhaps the universe itself had reminded this traveler of a forgotten path. Every time humanity measures the heavens more precisely, the edges of ignorance expand with it. The clearer the picture, the stranger the truth becomes. And now, somewhere between two planets, that truth had moved, not wildly, not violently, but with the grace of something that understood exactly what it was doing. Would you like me to proceed with part 2 next? Continuing seamlessly from this tone and pacing. You said proceed, ChatGPT said, stopped reading documents. Part 2 outside the control room, dawn broke pale and thin. Inside, the last readings of the night scrolled across the monitors, a sequence of numbers that refused to return to baseline. The telescopes, cooled and still, waited for silence to fill the gaps between data points. In that silence, a question began to take form, one so simple it felt dangerous. If something in the dark has changed direction, what exactly is it moving toward? To understand the anomaly, the scientists turned their gaze toward the traveler itself, the fragment they had been tracking for weeks without ever truly knowing. 3I Atlas, unremarkable in size, unassuming in brightness, was at its essence dust, rock, and frozen gases fused together in a forgotten corner of the galaxy. Yet the way those elements combined told a story far older than human civilization. It had no engine, no light of its own, no signal sent or received. Still, within its dim reflection lived a record, a journey stretching tens of millions of years across interstellar emptiness. When NASA catalogued 3I Atlas, It became only the third confirmed object of interstellar origin ever recorded by humanity. Its orbit pointed nowhere familiar. Its speed and inclination marked it as a wanderer from beyond. Not a returning comet, not a captured asteroid, a visitor from another sun. What fascinated researchers wasn't just where it came from, but what it was made of. Through infrared data from the NASA Infrared Telescope Facility and ESA's Gaia overlays, its spectral fingerprint revealed silicate minerals and carbon compounds similar to our comets, yet shifted in ways no known solar material could explain. Certain wavelengths hinted at exotic compounds formed only under deep space radiation. Its outer layer seemed layered like the rings of a tree, epochs of exposure etched into stone. Somewhere beneath that crust, traces of volatile gases slept. Carbon monoxide, methane, perhaps something stranger, but none of it was escaping. No jets, no coma, no halo of dust. Every other comet sings when it meets the sun. This one stayed silent. 3. I-Atlas behaved like a fossil, ice locked beneath an ancient protective shell baked by eons of cosmic weather. To the team at JPL, it wasn't a comet at all. It was cosmic driftwood, the fragment of a failed planet, torn from its birthplace and set adrift across the stars. Simulations hinted that it might have once orbited a red dwarf, where chemistry differs just enough to leave unique mineral scars. The object's surface appeared porous, like stone eaten by time, light scattering unevenly as if caught within a frozen sponge. Studying it was like reading a language carved before memory, photons acting as messengers from worlds long dead. Each reflected beam carried the echo of its birthplace, the fingerprint of time itself. It's humbling to think that matter can remember, that a grain of dust could hold the history of explosions, collisions, and forgotten suns, and that by chance, it drifted into our reach. There may be billions more like it, invisible until one brushes against our solar boundary. First came Oumuamua, then Borisov, and now Atlas. 3 interstellar wanderers in less than a decade, after thousands of years of silence. Perhaps the cosmic tides are changing, washing fragments of other systems toward us more often, each carrying its own memory of origin. The deeper scientists looked, the less simple Atlas became. Its rotation was uneven, somewhere between 5 and 7 hours, and yet rhythmic as though marked by design. Its reflectivity shifted gently, implying facets or edges that caught light like the folds of a broken mirror. Was it only the fractured shard of some larger body, or could its geometry be a clue? A pattern that spoke of how it had shattered, how it still turned. Such questions hovered between science and philosophy. When matter travels for so long, across so much space, does it cease to belong to any one world? Atlas seemed to whisper that space itself was not a void, but a field of stories still unfolding. The dust beneath our feet was once like this, drifting freely, before gravity bound it into planets, oceans, and life. Studying Atlas was like studying ourselves in reverse, watching creation undo itself into freedom again. To trace its orbit backward is to follow a ghost through regions that no longer exist, through radiation storms strong enough to scar atomic structures. Every photon that strikes its surface tells us it has survived places where most matter burns away, and yet, here it is, moving slowly through the light of our sun, the warmth of another star brushing it for perhaps the last time before it slips back into the cold. We see it now only for a moment, but in that glimpse we find our reflection, not in its silence, but in its endurance. Atlas doesn't speak, it remembers, and in that remembrance lies the quiet beauty of everything we still don't understand. By the 3rd week of continuous monitoring, the readings had settled into a rhythm that no one could ignore. 3i Atlas was slowing down, not drastically. Its drift through the inner system still seemed steady, but mathematically, the deceleration was real, measurable, and completely impossible. In the vacuum between Mars and Jupiter, there is no air to resist motion, nothing to slow an object once it's moving. And yet, the data from NASA's Jet Propulsion Laboratory, the European Space Agency, and Japan's ALMA array all aligned. Atlas was losing speed. Every engineer's instinct screamed for a mechanical explanation. Telemetry was checked, signal delays recalibrated, Doppler offsets reviewed line by line, but every cross-verification returned the same unshakable answer. The numbers were clean. The slowdown was happening, No external body could have caused it. No gravitational tug, no solar flare, no collision. The deceleration followed no curve of physics they recognized. It was too smooth, too deliberate, as though the object itself were quietly resisting motion. At JPL, the analysts gathered around a single chart that night, a velocity graph so subtle it could be mistaken for static. Yet within that fine slope there was defiance. The line flattened, not abruptly, but as if by choice. Hypothesis 1, outgassing. As sunlight warms a comet's frozen crust, jets of vapor burst from beneath, acting like tiny thrusters. But the thermal data disagreed. Atlas's surface temperature was far too low. No outbursts, no heat signatures, no trace of vapor trails. Hypothesis 2, the Yarkovsky effect, a gentle push caused by the uneven re-emission of heat as a rotating body absorbs sunlight. Again, the math failed. The timescale was wrong. Such effects take decades. This occurred within days. Each explanation fell away, leaving only a perfect question where an answer should be. One researcher suggested internal structure. Perhaps fissures venting trapped energy, or pockets of magnetic inclusions altering motion microscopically. Dozens of simulations were run, billions of variables tested. None of them reproduced the data. The deceleration pattern was too symmetrical, too precise. Then, someone noticed a faint connection. When they graphed the rate of slowdown against the angle of sunlight, a strange pattern appeared. Each time the sun struck a particular region on the surface, the object's speed dipped slightly, as if the light itself were touching something sensitive. This was not propulsion, it was response. In internal memos, NASA referred to it cautiously as a nonlinear photometric coupling, but outside the official phrasing, people simply called it what it was, a mystery. Could Atlas possess a structure, crystalline, hollow, or layered, that somehow amplified the pressure of light? We already know photons carry force, solar sails ride on it across space, but this was different. The slightest change in sunlight created a delicate, measured correction. Some physicists whispered that maybe this wasn't intelligence in the biological sense, but intelligence in matter itself. Could something formed by chance become self-regulating? Could the universe, through time and physics, build an object that behaves as though it were alive? At Caltech, one scientist ran resonance tests on the data. The results chilled everyone in the room. The object's motion pulsed in sync with its light fluctuations every 6 hours exactly. Spin, brightness, and velocity were linked like the rhythm of a heartbeat. In physics, rhythm means coherence, and coherence means structure. Atlas was not drifting. It was performing. Yet science refuses to leap toward wonder without proof. Could this be rotation? A trick of geometry? Perhaps. But the precision was uncanny. The phase difference between the light curve and motion was near zero. When the findings were presented in a quiet conference in Pasadena, laughter broke the tension for only a moment before silence returned. One researcher said, almost jokingly, "It behaves as if it knows it's being watched." No one corrected him, because deep down, every scientist in the room understood the weight of that sentence. Every act of observation changes the observed, and sometimes the cosmos seems to notice. Perhaps the most unsettling realization was philosophical, not physical. For centuries, motion has been seen as the result of force. Something moves because something else pushes it. But what if movement can also be memory? What if 3i Atlas carries within its stone the echo of an ancient force? A gesture that began before our sun existed, now playing out like the slow swing of a forgotten pendulum. Its deceleration might not be an act of resistance, but a final remembrance, a rhythm repeating until the energy that once began, it finally fades. By the end of the week, the graphs flattened into calm. Atlas had reached equilibrium, a perfect balance between motion and rest. It wasn't falling, it wasn't escaping, it was settled, somewhere between the pull of gravity and the silence of space. It found stillness, like a leaf that had finally learned to drift with the wind rather than against it. And so, late in the control rooms of Earth, surrounded by the hum of machines and the glow of monitors, one question lingered softly, carried on the air like static. If it wasn't gravity, and it wasn't chance, then what was guiding this traveler through the dark? For several months, astronomers around the world had watched 3i Atlas as a marvel of motion, a mysterious object gliding with silent precision through the emptiness between Mars and Jupiter. They had measured its light, its spin, its speed, and its stubborn refusal to obey familiar physics. But one cold night the mystery deepened, not through vision, but through sound. It began at the European Space Agency's Deep Space Listening Array in Spain. Buried within the faint electromagnetic reflections returning from Atlas's icy surface, technicians detected something that shouldn't have been there. An irregular modulation, not static, not noise, something structured, something rhythmic. At first, it was dismissed as interference. Cosmic rays often hum through the sensors. Solar wind can warp the signal, and sometimes the equipment itself sings when pushed to its sensitivity limits. But this was different. This was consistent. When the signal was cleaned and translated into audible frequencies, the control room fell silent. Through the speakers came a pulse, a slow, haunting rhythm, like a distant heartbeat hidden beneath static. It repeated. Once every 6 hours, the same rhythm that governed its brightness changes. Coincidence? Maybe, but coincidences don't usually survive peer review. Cross-verification began. Within days, 3 separate observatories, Spain, West Virginia, and Chile, detected the exact same modulation. When the data was layered together, the waveform aligned perfectly, like 3 instruments playing the same note across the void. ESA engineers called it an anomalous spectral resonance. It was faint, almost imperceptible, yet perfectly structured, too clean to be chaos. At the Jet Propulsion Laboratory, the data was sent for deep analysis. When the frequencies were plotted, they revealed something mesmerizing. The modulation wasn't flat or random, it breathed. Tiny shifts in amplitude rose and fell, with a grace that felt almost biological. It was as if the object were not emitting, but echoing, like a bell still ringing from a forgotten strike. Physicists compared the waveform to known cosmic sources, pulsars, plasma oscillations, magnetospheric interactions, yet nothing matched the symmetry. The rise and fall of intensity was too even, too intentional. To call it a message would have been premature, even absurd, but to call it noise felt dishonest. Within the data, the rhythm followed harmonic ratios, 1:2.3, patterns so rare in nature that they often signify structure, a kind of musical order written in electromagnetic language. Some researchers whispered the unthinkable. Could the universe itself be singing through it? The idea was poetic, perhaps even naive, but it clung to the imagination. As more observatories tuned in, the phenomenon became undeniable. The Green Bank telescope confirmed the signal, its sensitive dishes recording the same subtle hum, matching Atlas's known rotation. Even the ALMA array in Chile, primarily designed for sub-millimeter observations, detected faint traces, a whisper that refused to fade. The signal had a strange persistence. Even when Atlas passed partially behind the Sun, when direct observation should have been impossible, the resonance lingered. Fainter, yes, but still measurable. That defied logic. It was as if the hum wasn't coming from the object anymore, but around it, an echo reverberating through the plasma of the solar wind itself. Theories multiplied, colliding and collapsing under scrutiny. Some argued that Atlas was resonating like a conductor, its structure amplifying electromagnetic vibrations the way a crystal amplifies light. Others suggested the signal was not emitted at all, but a side effect of its motion, the way a boat leaves ripples even after passing. But even among skeptics, one truth became inescapable. The pattern was too precise to ignore. The hum was not chaos, it was order. When one NASA engineer overlaid the signal against the infamous 1977 WOW radio burst, the similarity in shape was striking. Not identical, but close enough to provoke nervous laughter across the conference room. The official report dismissed any comparison, labeling it superficial correlation. Yet privately, no one could shake the unease. In the months that followed, models tried to explain how an interstellar rock could sing. Some invoked magnetic induction, sunlight charging the minerals in its crust until they vibrated. Others thought of piezoelectric reactions, the kind found in crystals that convert stress into electricity. But none of those theories could account for the consistency, the near-perfect tempo that endured across weeks and distances. Then, another discovery emerged. The amplitude of the hum, its strength, began to rise. gradually, steadily, as if the object, having crossed a threshold in its journey, was responding to something unseen, a change in solar alignment, perhaps, or something even subtler. At first, the increase was small, a whisper growing barely louder than the background radiation. But to the scientists who lived and breathed data, it felt alive, deliberate, aware. Some dismissed it as atmospheric noise, others called it coincidence, but a few refused to look away. One researcher at ESA's listening center wrote in his log, "It's not a signal, it's a rhythm." And the rhythm remembers. Late at night, when the hum played softly through the lab speakers, stripped of static and distortion, it sounded less like an alien message and more like something older, something the universe had been humming long before we learned to listen. The more they studied, the clearer it became. Pattern is the true language of the cosmos. Every atom vibrates, every orbit resonates, every star sings. Perhaps Atlas was not speaking to us. Perhaps it was simply joining the chorus, its voice rising just high enough for us to notice. And as the data streams poured in, one final pattern emerged. The harmonic intervals shifted slightly every 27 days, mirroring the rotation of the sun itself. That was impossible. And yet, there it was. A synchronization across 93 million miles of emptiness. No one knew what it meant, but everyone knew what it felt like. It felt like the universe had just breathed. And for the first time in a very long while, we had heard it. By the time 3I Atlas completed its silent arc past the orbit of Mars, the world of science had already begun to fracture, not out of disbelief, but because belief itself had become divided. What had started as a minor curiosity, a dim speck deviating by half a degree, had now become a philosophical fault line that split laboratories, conferences, and entire disciplines. The equations were correct, the data reproducible, and yet the conclusion felt heretical. Something in the void had responded. At NASA's Jet Propulsion Laboratory, the official stance remained conservative. The agency refused to invoke words like anomaly or signal. Every report was phrased with surgical neutrality, photometric irregularities consistent with complex surface interactions. But beneath that polished language, scientists whispered. They spoke in metaphors again, the way early astronomers once did before data replaced myth. One engineer compared Atlas to a listener, a body that did not transmit or speak, but responded subtly and intelligently. To the gaze fixed upon it, the name caught on, the listener. What had once been a sterile catalog code, 3I 2025 Atlas, had acquired a soul. In coffee rooms and message threads, the words spread, not discovery, but communion. When NASA projected Atlas's trajectory forward, the line that appeared on their models defied the logic of celestial mechanics. The object was not falling into the sun's gravity well. It was slipping away, curving outward, as though it had found an invisible corridor through the solar wind. To those who traced the map, it looked less like defiance and more like surrender. A surrender to some deeper rhythm of space. Perhaps that was all this was. Not resistance, but alignment. Space offers currents we barely understand. Subtle pathways where electromagnetic pressure balances perfectly against gravitational pull. Maybe Atlas had simply drifted into one. Maybe it was listening to something we could not hear. Still, there was poetry in the act. When scientists plotted its evolving route, the path looked not like a collision course, but like a retreat, a graceful exit from the gravitational theater of our sun, like a traveler who had paused only briefly to glance our way before continuing its endless journey. At the European Southern Observatory, a young astrophysicist named Riva Tariq spent nights overlaying the brightness data across its new course. Each plot she made, each luminous dot scattered across her screen, seemed to tell a story not of chaos, but of memory. The pattern repeated every few rotations. A delicate pulse, a deceleration, then silence. If Atlas were a machine, it would be malfunctioning in perfect rhythm. If it were alive, it would be breathing. Riva wrote in her notes, "It drifts as though remembering." Her mentor, a veteran of the Oumuamua studies, replied simply, "Then perhaps memory is the physics we don't yet understand." In Pasadena, mission planners debated whether to redirect a probe to intercept it. Perhaps the old New Horizons craft, now drifting at the edge of the heliosphere. But the idea died quickly. The distances were too great, the trajectory too unpredictable. By the time an intercept mission reached it, Atlas would already be gone, vanishing into the cold fog of the Oort cloud. Still, not everyone could let it go. Simulations were run night after night, some in secret. The software projected the object's position a decade ahead, a faint blue curve bending outward, away from the ecliptic, heading for the threshold where sunlight fades to starlight. Within a few years, it would fade beyond every telescope's reach. Yet even as it slipped from view, it left behind a signature, a subtle curvature written across the data, a whisper etched in orbital history. To those who watched it night after night, the feeling was bittersweet. Every measurement, every chart, every number recorded was an attempt to hold on to something that was never meant to stay. There is a particular kind of melancholy that comes from mapping the unknowable, from tracing the edges of something that refuses to be owned. Still, humanity maps it anyway. We map because we must, not to conquer, but to understand the outline of our own ignorance. Among the research community, discussions grew more metaphysical. Was Atlas an accident of nature or an expression of some universal principle we had never recognized? Could there be regions of space, rivers of invisible flow, where matter simply remembers the forces that once shaped it and follows them like instinct? A particle physicist from Kyoto phrased it beautifully during a symposium. Perhaps space is not empty at all. Perhaps it is memory made visible. The audience didn't clap. They simply sat, listening, as though afraid that applause might drown out the quiet truth hidden in her words. As the final images of Atlas came in, they showed nothing dramatic, just a single, dim spark moving slowly across the black. No flare, no tail, no explosion. Only motion, only patience. Only motion, only patience. The last confirmed photograph captured by the Subaru telescope displayed a faint silver streak trailing behind the point of light. A trick of exposure, perhaps, or something more. To most, it was an artifact. To others, it looked like handwriting, a single graceful curve drawn across the darkness. A message, perhaps, written not in words, but in trajectory. By then, scientists had stopped asking whether the object was alive. That question suddenly seemed small, even childish. The more profound realization was this: the universe itself behaves as though it remembers. Atlas had reminded humanity that motion is never merely movement. It is continuity, the conversation between what was and what will be. And so, as it drifted farther from the warmth of our star, the data streams grew weaker, then silent. But even in that silence, something remained, an echo woven into the background hum of the cosmos. Somewhere beyond the reach of any telescope, Atlas continues its journey unmeasured, unseen, and yet, because we once looked upon it, because our attention brushed its path, it is no longer forgotten. When 3i Atlas finally disappeared beyond the range of Earth's most powerful telescopes, the world of science did not fall silent. It exhaled, slowly, cautiously, as though humanity had just finished holding its breath for too long. For weeks, data streams trickled in, faint and fragmented, until even the last echo of reflected light faded into noise. The numbers stopped changing, the graphs went flat, the screens went dark, and in that darkness, something unexpected began to happen. Not out there in space, but here, among those who had been watching. In the months following Atlas's vanishing, the feverish debates cooled. The conferences that once buzzed with argument turned into gatherings of quiet reflection. Papers were still published, but the tone shifted. Equations shared space with metaphors, footnotes with poetry. The language of certainty softened. Scientists began to write less about what Atlas was and more about what it meant. Across the community, a new phrase emerged: phenomenological astronomy, a discipline that sought not only to measure the cosmos, but to understand the act of seeing it. The premise was radical in its simplicity. To observe is to participate, and participation changes both observer and observed. Atlas had forced everyone to confront this truth. Every telescope that had turned toward it, every calculation, every photon caught in a sensor, all of it had become part of a shared moment between matter and consciousness. At NASA, a quiet proposal circulated through the internal network, an idea so poetic that it felt almost like prayer disguised as engineering. It was called Project Lurus. Unlike previous missions, Lurus would not chase the next interstellar object. It would listen for them, not for their light, but for their rhythm. A deep space observatory designed not to see, but to hear the faint breathing of the cosmos, the hidden oscillations of matter moving against the grain of gravitational law. The proposal ended with a single line typed in italics: "We will not call to the stars. We will listen, and perhaps one day they will remember that we did." No one in the committee changed that sentence. Not one word. Meanwhile, around the world, observatories began to host open nights, gatherings that felt more like vigils than scientific demonstrations. Students, astronomers, and ordinary citizens stood beneath clear skies, staring into the darkness where Atlas had once been. They projected its final path on dome ceilings. They replayed the faint hum it had once echoed, but inevitably, conversations turned inward. People no longer spoke only about orbital decay, velocity, or light curves. They spoke about how it had made them feel. Small, fleeting, but also connected to something vast, impersonal, yet deeply intimate. One scientist described it best. When we looked at Atlas, we weren't just observing a rock. We were observing the continuity of wonder itself. In an age obsessed with certainty, Atlas had reintroduced humility. It reminded the world that science was born not from answers, but from awe. Before equations and instruments, there was only the night sky, and human eyes searching for meaning in the silence. The astronomers of old did not divide knowledge from reverence. To name the stars was to worship them, not in superstition, but in gratitude. And in its quiet passing, Atlas rekindled that lineage. It reminded everyone that discovery is not conquest, that every insight should deepen, not diminish the unknown, that perhaps the purpose of knowledge is not to extinguish mystery, but to fall more deeply in love with it. Months after the final transmission, one of the last confirmed images of Atlas resurfaced. It wasn't spectacular, just a blurred dot of light on a black field, but upon closer inspection, a faint silver streak appeared behind it. To most, it was an artifact of exposure. To others, it looked like handwriting. A graceful, sweeping curve drawn across the void, a gesture that felt intentional, almost human. It wasn't proof, it wasn't evidence, it was something rarer, a reminder that meaning is not always found in clarity. Sometimes it lives in the blur, in the streak left behind by something that refused to stand still long enough to be fully known. Even after the data was archived and the satellites turned their dishes elsewhere, some scientists refused to let go. Late at night, they reopened the old files, reran the algorithms, refined the noise filters, searching for even the faintest residual trace. Most found nothing. But every so often, a flicker appeared, a small numerical blip rising above the background radiation, so faint it vanished before it could be confirmed. Each time it happened, someone in the lab would pause, listening, not for sound, but for pattern. Because that's what Atlas had taught them. The universe rarely speaks in words. It speaks in continuities, and in that delicate pulse of probability, they found a strange comfort. One researcher wrote in her final note before retiring the dataset, "Perhaps Atlas did not disappear. Perhaps it simply fell silent again, waiting for us to listen differently." Far beyond Pluto, beyond the reach of radio and light, Atlas continues its quiet journey. No longer seen, no longer measured, but not forgotten, because somewhere, on a pale blue world spinning beneath its own atmosphere, there remain those who remember the night the universe moved, ever so slightly, as if acknowledging that it had been seen. Long after 3, Atlas slipped beyond the reach of telescopes. Something curious happened across the world of science. The chatter dimmed, the urgency softened. The fierce debates that had once filled conferences and live streams gradually gave way to a quieter rhythm, a rhythm of contemplation. New papers still appeared in journals, but their sentences read differently now, less declarative, more poetic. They carried a hesitation, the awareness that perhaps what had been glimpsed could not be entirely measured. Among astrophysicists, a subtle cultural shift began. Atlas was no longer treated as an anomaly. It became a threshold, a boundary between the measurable and the ineffable. Students spoke of it with the same reverence artists give to their muses. Senior scientists, once skeptical, began to describe their work not only in the language of equations, but in that of experience. One symposium in Geneva even carried a new title on its invitation card: Atlas and the Return of Wonder. At NASA's headquarters, a smaller working group carried forward the idea that had been born in whispered conversations during Atlas's observation period. Their proposal, once an unofficial memo, now had a name written in bold lettering across its first page: Project Lurus. The goal was as unconventional as it was profound. Lurus would not seek to intercept the next interstellar traveler. It would listen. It would tune its sensors not to brightness or motion, but to rhythm, the faint resonances that might betray the presence of matter moving with intention, or perhaps memory, through space. Instead of another high-thrust probe or telescope, Lurus would be a network of deep space receivers, orbiting far from Earth's magnetic noise, designed to hear the breathing patterns of the cosmos. Its concluding statement became legendary within the agency: "We will not call to the stars. We will listen, and perhaps one day they will remember that we did." For once, no committee edited the sentence. It passed unaltered through every draft, a rare consensus among scientists who suddenly understood that listening could itself be an act of discovery. Outside the institutions, the public responded differently. All over the world, observatories opened their domes to visitors. People who had never touched a telescope stood in long queues beneath cold skies, waiting for their turn to look into the same darkness that had once held Atlas. Some came for answers. Most came for silence. They found both. Astronomers projected the final trajectory on planetarium domes. They played audio recreations of Atlas's light curve, transformed into low, pulsing tones. In the darkness, hundreds listened together. The hum of the interstellar traveler echoing through speakers like the heartbeat of something vast. Soon, it became a ritual. Every few months, cities hosted Atlas Nights, sky-watching events without telescopes, just open fields and collective quiet. Children lay on blankets beside retired engineers, poets beside physicists, everyone facing upward in mutual unknowing. When journalists asked participants why they came, the answers were strikingly similar: to feel small, to remember what silence sounds like. Because for one night, science and wonder speak the same language. In Cambridge, a philosopher of science named Dr. Elena Marin published a paper that quickly crossed disciplines. Her argument was simple: that Atlas had exposed a forgotten aspect of human knowledge, that understanding is not possession. She wrote, "Every measurement is a confession of desire, the desire to make the unknown familiar. Atlas reminded us that the unknown is not the enemy of truth, but its companion." The essay spread beyond academia. It appeared in magazines, documentaries, and even art installations. Painters began to depict the interstellar traveler as a symbol of humility, a cold shard of rock carrying warmth in the form of human attention. Back in Pasadena, the control room that once buzzed with numbers now stood quiet. A single screen still displayed the frozen trajectory, the last known path fading into black. The cursor blinked in the corner, a silent metronome marking the end of one story and the beginning of another. Some of the same researchers who had spent sleepless nights analyzing data returned to that room years later. They stood before the screen, watching the static map, as though expecting the line to move again. It never did, and somehow that felt right. Because by then, they understood that stillness can be a kind of motion too. The motion of meaning traveling from one consciousness to another. Outside, the city lights of Los Angeles flickered beneath a thin marine haze. Above them, hidden by glare, the stars continued their eternal choreography, unaware of how much they had changed the minds that once watched them. In that same night sky, somewhere far beyond Pluto's orbit, Atlas kept drifting, its path now unmeasured, its rhythm unrecorded. Perhaps it had found another corridor of calm, another invisible current through which to move. Perhaps it had ceased to move altogether. No one knew, no one needed to, because what Atlas left behind was no longer just data. It was a mirror, reflecting how deeply humans yearn not merely to know the universe, but to feel it noticing them in return, and somewhere, deep within the hum of cosmic background radiation, every listener who had once heard its pulse could still imagine it, faint, rhythmic, eternal. as if the universe were whispering a memory back to those who had cared enough to listen. As 3I Atlas continued its silent drift into the void beyond the heliosphere, the signal of its existence faded from every screen on Earth, but not from memory. The data, now archived across multiple observatories, became something more than science. It became a story, one that refused to end. Months after its disappearance, the last echo of its telemetry was played in the control rooms one final time. A faint sequence of beeps, the rhythm that had once seemed meaningless, pulsed through the speakers like the final heartbeat of a distant creature. No one spoke. There was nothing left to calculate. Yet even silence, the scientists realized, can be full of information. They watched the frozen graphs on the monitors, lines that had once danced with life now flat and still. It felt less like the death of a mission and more like the end of a conversation, one side trailing off mid-sentence. And that, perhaps, was the lesson Atlas left behind. Some stories are not meant to conclude. They simply dissolve into mystery. In the archives at the European Space Operations Centre, a single researcher continued running periodic scans. Every few weeks, she filtered the background radiation from the edge of the solar system, searching for any residual signal, a flicker, a deviation, a mathematical whisper. Almost always, there was nothing. But on rare nights, something would appear, a small fluctuation barely above the noise threshold, a flicker so faint it could vanish with the next calibration. Each time, she logged it carefully. Minor amplitude anomaly detected, pattern inconclusive. Then, almost as ritual, she would listen to the translated frequency. The hum so low it barely existed, just a breath of vibration through the lab speakers. And in that moment, it was as if Atlas were exhaling across eternity. She knew it wasn't proof of anything, but the sound had a rhythm she couldn't quite ignore, a rhythm that felt familiar. Elsewhere, the Project Lurus initiative quietly moved forward. Its designs had changed, sleeker, more symbolic than functional. Instead of high-gain antennas or deep-range propulsion, it featured massive resonant discs, polished composites engineered to vibrate at frequencies, matching the faint harmonic intervals. Once traced from Atlas's hum, it was an observatory, built not for sight or travel, but for sympathy, to vibrate in unison with the cosmic music that might still be playing out there, somewhere. At its core was a new kind of sensor, calibrated to detect pattern, not signal, coherence, not strength. As the head of the project described it in a memo, "We have spent centuries looking outward. Perhaps it's time we let the universe come to us." Public fascination with Atlas never entirely vanished. Artists, writers, and composers transformed the data into paintings, novels, and symphonies. One orchestra in Berlin even performed the Atlas Frequencies, a haunting composition built entirely from the translated hum of its recorded resonance. The performance ended with 6 long measured tones, the same interval that had defined its spin. As the final note faded into silence, the conductor held his hand suspended in the air for several seconds, as if waiting for a reply that would never come. The audience didn't applaud immediately. They sat still, breathless, listening to the echo of what was no longer there. Years later, when students studied the Atlas files, they encountered not a story of aliens or miracles, but of attention, what it means to notice something fleeting and to allow wonder to change you. In lecture halls, professors quoted a line that had become almost sacred within astrophysics. "To observe is to participate." That sentence, simple, quiet, undeniable, had reshaped the philosophy of science itself. Observation was no longer seen as interference, but as relationship. The universe, they said, doesn't just reveal itself, it responds. And so, somewhere far from the warmth of the sun, Atlas drifts, silent, perhaps dormant, perhaps listening. Its motion through the dark is no longer tracked, yet every simulation agrees on one point. Its trajectory continues to shift, ever so slightly, as if following a path written not by gravity, but by memory. If we could see it now, that lone fragment of stone and ice moving through the unlit corridors between stars, it would look ordinary, unremarkable, but those who once studied it know better. They know that within its cold shell lies the record of countless forces, collisions, radiation, time, all intertwined into something that resembles will. Not intelligence as we define it, but persistence. One of the final documents in the Atlas archive contains a single sentence, unsigned and undated. No one knows who wrote it, but it has since been engraved on the wall of the new Luris facility. Maybe Atlas was never visiting us. Maybe we were the ones passing through its memory. Years passed, and 3i Atlas became less a discovery and more a legend whispered between disciplines. A modern parable that no one dared call fiction. At first, its name appeared in textbooks and symposium lectures as a case study in anomaly, but slowly its meaning evolved. Atlas was no longer just an astronomical object. It had become a symbol of humility, of connection, of the strange reciprocity between human attention and cosmic indifference. Within universities, young astronomers cited Atlas in their dissertations, not to prove hypotheses, but to question them. They began to ask, what if discovery isn't the end of mystery but its continuation? What if the universe isn't a stage we observe, but a mirror that moves when we look? In one recorded seminar at MIT, a lecturer summed it up perfectly. Atlas is a reminder that even silence can contain information, and that sometimes the universe answers by simply existing. Project Luris, once dismissed as poetic idealism, had become operational. A series of thin reflective stations floated beyond the moon's orbit, silent except for the gentle hum of resonant disks calibrated to the faint harmonics of cosmic background radiation. The system didn't transmit, it didn't beam or probe, it listened. To the light pressure of distant particles, to the small vibrations of gravity waves, to the music of space too faint for ears or machines to call sound. At its heart, a central data core was built to detect patterns of coherence. It ignored random noise, searching only for repeating intervals, signals that remembered themselves. For months, it heard nothing but the static of infinity. Then, one day, a flicker appeared, a pulse, weak, distant, familiar, every 6 hours precisely. The staff dismissed it as coincidence, but one scientist, older now, grey at the temples, the same researcher who'd once watched Atlas fade beyond the sensors, refused to ignore it. She compared the new signal to the archived Atlas frequency. They matched, not exactly, not perfectly, but close enough to stir the room into silence. The same rhythm, the same harmonic spacing. Could it be back? Someone whispered. No, she said softly. It never left. We just learned to listen again. Weeks later, the Luris network began to record an unusual phenomenon. The signal was not approaching. It was resonating, as though coming from everywhere and nowhere at once, like a chord struck across the entire fabric of space-time. Some physicists theorized that Atlas had reached a region where matter becomes diffraction, a realm where an object stops being a single point and starts existing as a pattern, smeared across distance like ink through water. If true, then the signal wasn't just from Atlas, it was Atlas, transformed, diffused, still moving, but no longer bound to a singular trajectory. Its journey had evolved into frequency. Its motion had become song. At the Luris station, engineers began translating the resonance into light, mapping amplitude to brightness, frequency to hue. On the screen, an image appeared, a slow, rippling wave of faint blue and silver shifting across the black. It wasn't data. It wasn't language. It was art. To some, it looked like the aurora of a dead world. To others, like breath caught in glass. But to those who had followed the Atlas mission from the beginning, it looked like memory made visible. The world reacted quietly. There were no press conferences, no sensational headlines, just a single update on the Luris website. Resonance detected. Source indeterminate. Pattern recurring every 6 hours. No conclusions, no claims. Just the rhythm, continuing. At an observatory in Chile, a technician left a note on the console before going off shift. It read, maybe Atlas was never a message from the stars. Maybe it was an echo of us learning how to listen. And perhaps that's how it was meant to end. Not with revelation, but with recognition. Because sometimes, the universe doesn't give us answers. It gives us a reflection. And if you listen long enough, if you truly listen, you realize that reflection sounds a lot like your own heartbeat, returning from the dark. It had been 10 years since 3i Atlas vanished beyond the heliosphere. 10 years since the final image, the the faint silver streak against black, was captured and archived. The world had moved on, as it always does. Missions were launched. Stars were mapped. Humanity returned to its ordinary business of measuring infinity. And yet, somewhere beneath all that forward motion, the story of Atlas endured, quietly, insistently, like a memory that refuses to decay. In a small planetarium outside Pasadena, an old projector whirred softly as it cast the final recorded path of Atlas across a domed ceiling. Children sat cross-legged on the floor, watching the thin white line sweep outward until it disappeared into nothing. The lecturer, a retired NASA analyst who had once monitored the object's trajectory, spoke not of data, but of wonder. "We watched it for months," she said, "and when it was gone, we realized we hadn't been studying a rock at all. We were studying our own need to understand." She pointed to the vanishing streak. "That," she whispered, "is what curiosity looks like when it leaves home." The audience sat in silence. For once, no one applauded. Some simply closed their eyes and let the darkness of the dome wash over them, like standing beneath the night sky itself. Far above Earth, Project Luris continued to listen. The resonant disks drifted through the quiet between planetary orbits, turning gently, vibrating to the unseen hum of cosmic background rhythm. Most days, the recordings yielded nothing but statistical noise. But every so often, always at the same interval, every 6 hours, a faint tremor shimmered across the sensors. It was not strong enough to prove anything, not distinct enough to draw conclusions, but it was there. Somewhere in that signal, amid the static of creation, the shape of Atlas persisted, its rhythm unbroken, its silence intact. The Luris engineers stopped trying to define it. Instead, they began to archive the silences themselves, labeling each one as interval 0, the space between pulses, the pauses that contained everything and nothing at once. Over time, those pauses filled entire libraries, and in them, a strange peace took root. The understanding that the absence of answer can itself be an answer. On Earth, artists continued where science paused. They painted Atlas not as a comet or stone, but as a concept, an echo traveling through thought. One sculpture in Iceland depicted a spiral of silver thread vanishing into fog. Another installation in Tokyo used beams of light to simulate the 6-hour heartbeat of the traveler. Visitors stood between the lights, feeling them flicker across their skin like the pulse of something watching gently from far away. Documentaries were made, poems were written, but what lingered most were the questions. How does matter remember? Can silence be communication? Is the universe aware of being observed, or does our observation create its awareness? There were no answers, only an expanding sense of intimacy with the unknown. In a late-night interview, one of the Luris physicists, her voice calm, her eyes reflecting years of quiet devotion, was asked what she thought Atlas truly was. She smiled. "Everything," she said, "in the universe vibrates. Even we do, every atom of us is rhythm. Maybe Atlas was just the first thing to teach us to hear it." She paused, then added softly, "I don't think it ever left. I think it's still out there, drifting, humming, not to be found, but to remind us that we're part of the same song." One night deep in winter, as the Luris array orbited in perfect alignment with the solar wind, the instruments registered something new. Not a pulse this time, but a swell, a rising harmonic unlike any recorded before. It lasted only 23 seconds, then silence. Analysts spent months reviewing it. Some called it interference, others called it resonance. No one could agree. The official report filed it as unclassified harmonic event, source unknown. But among the few who had waited their entire lives for one more whisper, those seconds were everything. Because within that rising tone, faint though it was, the familiar 6-hour interval could still be traced, folded, inverted, echoing through itself like an answer hidden in its own question. And though no one said it aloud, everyone who listened understood. Atlas had spoken again. The signal was archived, the data verified, and then life moved on, as it always does. The hum faded, but its echo remained, not in machines, but in people, across classrooms, observatories, and lonely backyards. When someone pointed a telescope at the night sky and whispered, "I wonder," the story began anew. Because that was the real gift Atlas left behind. Not revelation, but wonder reborn. It reminded us that knowledge and mystery are not opposites, but partners. That discovery is not possession, that the universe doesn't owe us answers. It only invites us to keep asking beautifully. Somewhere beyond the reach of any instrument, 3I Atlas drifts on, unseen, unmeasured, a traveler stitched into the dark fabric of time. It doesn't shine. It doesn't call. It simply moves, steady, rhythmic, remembering. And though no one can see it now, the whole of humanity carries its trace. In every equation written, every telescope aimed skyward, every heartbeat that quietly syncs with that distant rhythm. Because maybe Atlas was never a visitor at all. Maybe it was a reflection, the cosmos reminding us that we too are fragments of its endless memory, still learning to listen, still learning to drift gracefully through the light.